Hi everyone. This session is dedicated to review of a grade 9, the shape of displays. So normally it is a statistical thing going here. So first of all, we want to review about the shape of a given distribution. So normally the general shape of distribution, we should know that the shape of a distribution always provide information about the scores. Okay, we mean here by the scores or the result of the observations of a statistical survey. Okay, so normally in general or in sometime the graph of a distribution can be symmetric. We mean by symmetric when we have a bell-shaped curve or a normal distribution. So normally we are talking about the symmetric distribution, like here, a bell shape. So well distributed, symmetrical distributed. Okay. But in general, the distribution is not symmetric. So normally we say that the distribution is skewed. Okay. So the distribution can be positively skewed or negatively skewed. When the distribution is positively skewed and when the distribution can be negatively skewed. So normally we can use the graph or some plots to represent the distribution when it is positively skewed and the distribution when it is negatively skewed. So normally we can use when we can use the tail of the data. We have the distribution of the data here with represented with the green curve. And so normally we have a tail here, so we have a tail here, so the distribution isn't symmetric, so we call it skewed. So normally when the tail is to the right, okay, so normally we say it is positively skewed. When the tail is on the left, so we say it is negatively skewed. Also, when we have, we should know some important vocab in statistic, like the mode. What we mean the mode? The mode is the score, okay, the data that appears the most in our survey, or we can say the mode is the score with the highest frequency, the most repeated one. So some distribution have two modes, like we see in this graph, in this plot. We have two maximum. So normally we have two modes. So we call this distribution by bimodal distribution. Okay. Oh, we want in this session to review some to give a review on some histograms and the plots. We have the back-to-back histogram and the dot plot. Normally, with the back-to-back histogram, we can, for example, compare two different data for the same statistical study. Okay, and we have a dot plot. We call it as dot plot because we use a dot to represent the repetition, the number of dots represent the repetition of the frequency of a given score. Okay, so for example, we have a here table show the monthly and annual rainfall for Sydney from 2002 to 2011. Okay, so the measurement are the nearest millimeter. So we have all around the months of the year from the year 2002 to 2011. So we should perfectly, for example, choose the column or the row that represents the appropriate question. So the convenient one. And this, for example, in this time period, in which year was the annual rainfall? In this time period, so for example, we are in March. Currently, we are in March, so we should enter the column. The interested column is for March over all these years. Okay. In which year was the annual rainfall highest? So the highest is, for example, it is clearly remarkable that 349 is the highest number, the highest value from all these Mars. Normally in 2003. So in 2003, the highest is in March here is like this May. Okay, we have 132, 145, and 192. So in 2011, the rainfall was or the year where when the rainfall was the highest. Okay, lowest. So the lowest is clearly in, for example, 2060 with 40 nearest millimeter. Okay, how much rain fell in July 2006? So we should know that January, February, March, April, May, June, and July. So this is July for us on in 2006. So we should, for example, find where we are we using, for example, 140. The rain fell 140 millimeter fell in July 2006 and June 2007. So normally it is June 2007. So normally 511. Okay, and so on. Which month had the highest rainfall in 2011? For example, highest rainfall in 2011. So we are interested in the last row here with these values. We can clearly see that, for example, the highest value is the highest value was here 2,282. July. So the month is July. What month had the lowest rainfall in 2005? So we are interested in this row, 2005. The lowest, so the lowest really is in August, and so on. So you should to study well or to find the correct answer to restrict your choices with respect or convenient and appropriate, very relevant to the given. Okay. Moving on to the next exercise, state whether the shape of each distribution is symmetrical, positively skewed, negatively skewed, could be model. We have two maximum here, so it is a bimodal. The tail is to the right, so positively skewed. We have a bell shape, so symmetrical. We have the tail to the left, so negatively skewed, easy. Moving on to the third exercise, we have two teams, Team A and Team B, and we are interested on the distribution of the number of goals per match scored by two score teams. So normally they ask us to display this information in a back-to-back histogram and parallel dot plot. So these two plot or histograms to represent or to compare between the two distributions for the same subject. So for example, the back-to-back histogram for team A and team B. We can, for example, in vertically use the score, a column for the different scores or number of goals. So 0, 1, 2, 3, and 4, oriented from the bottom to the top. And we have to the left and to the right the team A and the team B respectively, the frequency of this one. So normally we can use like rectangles, horizontal rectangles to show the frequency of each score for each team, and we obtain this one. Okay. And the parallel dot plot, for the parallel dot plot subject, we can, for example, we can draw two parallel two parallel line, okay, for each team. In this line, we can, for example, put the different scores or the different number of goals, and with the dots, we represent the number of dots for each score represent its frequency. Like we have here, with, for example, for 0, we have a 6 number of matches for team A. So we have a 6 dots for team A. We have a 6 dots, 1, 2, 3, 4, 5, and 6, and so on. Okay. And they asked about the shape distribution, like a bell shape, for example. So it is approximately symmetric. Here we have a tail to the right, so positively skewed, and so on. Compare the mean, median, and range for these two distribution. We should have look and review about the mean. The mean is the sum of scores over the number of scores. The median, okay, the median equal to the middle score, and the range equal to the highest score minus the lowest score. Normally, for both teams, we can, for example, the highest score is 4, 4 minus 0, the lowest, and 4 minus 0 is 4, so the range is constant for two, the same for the both teams. Okay, about the mean, it is easy to calculate and evaluate the mean for each team. How? It is like the summation of six. We have a 6 matches where they put 0 goals and 8 for 1 goal, and so on. So normally we multiply 6 by 0 plus 8 by 1 plus 4 by 2 plus 0 by 3 plus 2 by 4. And then after evaluating this summation, we divided by the number of goals or number of matches. Okay, so normally here we evaluate number we divided over the number of matches, so we will obtain 1.2 here, and for the team B we obtain 1.85. What about the median? So normally we can cancel from both sides. How? For example, we can use the dot here, the dot plot for team, for example, for team B. Normally we start to cancel from both sides, from the left, the bottom left to and respectively from the top right, and so on. 1 here, and normally 1 from here. By order, 1 here, so normally from the top. We continue from the left and bottom to the top. Left, bottom, and top. Okay, left, bottom, and and top. Left, bottom, and top. Left, bottom, and top. Okay. Normally we will have 2. We'll obtain 2 normally. We obtain 2 middle scores. So when obtaining two middle scores, so we add these two middle scores and we calculate the average. 2 plus 2 over 2 average. So we divided by 2 the sum of these two middle scores. We divided by 2 to obtain 2. And same for the team A. We do the same, and to obtain two middle scores, finally we calculate the average, dividing these the sum of these two values by 2 to obtain 1. So normally the mean and the median of team B are greater than those of team A. So as a result, we can say that the team B performed better than A. So this is the end of our session. Thank you for listening. Bye bye.